Hello.
Hello, sir.
Hello,
Hi.
sir.
Yeah. So we'll try and finish the chapter today, binomial theorem. Uh, last class, what was the last point that we had done? We are doing some series, right?
Yeah, the
Yes, sir.
series ones we are doing.
Some series examples we were doing, right?
Yeah.
Okay. So what we will start off with today is we'll do the theory of this multinomial theorem, and then we'll continue back to some problems and all.
Yeah. Okay.
So multinomial theorem will finish, and we'll do some questions and some more series questions and whatever else is there. There is not much else left. Only multinomial theorem you have to understand. So, okay. So binomial theorem, we already know what it is. It is something that tells us how to expand this, right?
Yeah.
So multinomial, as the name suggests, it will have not just two terms, it will have multiple terms. And let's say we have to expand this, right?
Yeah.
So how do we expand this? That is the question. And multinomial theorem gives us a way to expand that. Okay. So
Yeah.
what we will try to understand is how to figure out the expansion. Two things we need to find. How to find a general term here. Find a general term for this. Just like here we found a general term as this. X power n minus r, y power r, right?
Yeah.
In the binomial theorem, we knew that this is the general term.
Yeah.
Yeah.
And basically, r goes from 0 to n.
And yeah.
Similarly, I want to find a general term for this expansion. And I also need to find out how many terms will appear. How many terms will come, right? Because in binomial theorem, that part was obvious. There will be n plus 1 terms.
Yeah.
But here it might not be obvious. So we'll think along those lines. These two questions we want to answer. So first of all, notice that whenever you raise something to the power r and all, to the power n, right? Every term in the binomial series had degree n.
Yeah.
Every term. Correct? So
Yeah.
when
Yeah.
powers of x were increasing, powers of y are decreasing.
Decreasing.
And the addition of the powers has to be n. Okay.
Yes.
So
Yeah.
the first thing that we will see here is that if I want to write some coefficient a, y power b, z power c, right?
Yeah.
Then obviously a plus b plus c must be equal to n,
Yeah.
right?
Yeah.
That has to happen. It's not like you will ever get a situation where a plus b plus c is not equal to n, right? So let's think about how many such terms will come, right?
Yeah.
Where a plus b plus c is equal to n, and a, b, c can be arbitrary values, right?
Yeah.
It has to be non-negative integers. It has to be 0 or 1 and so on. It can go up to
Yeah.
n, and we want to figure out how many such terms will come, right?
Yeah.
Yeah.
Okay, so let's think about it. X plus y plus z to the power n can be written as x plus y plus z, x plus y plus z, x plus y plus z. How many times? We have to do it n times. Correct? There are such n brackets, and you want to make a term called x power a, y power b, and z power c,
C.
such that a plus b plus c is equal to n,
N.
right? So,
Yeah.
Yeah.
so let's try to make one such term. So how will you make such a term? Out of these n brackets, how many x's do you have to select?
And
A x's. No?
A.
yeah.
Out of the n brackets, you will select x.
Sorry.
A
Yeah.
brackets
A
where
times,
you will
yeah.
take the x, right?
Yeah.
And you will
Yeah.
multiply those a. So how many ways can you select a x's? Select a x's from n brackets, right?
Yeah.
That number of ways to do that would be how much? NCA, right?
Yeah.
This we have understood, no? NCR means number of ways
Yeah.
of selecting R things out of n things, right?
Yeah.
Yeah.
So this is NCA. But that we are not done yet, because at the same time, you have to select how many y is, right?
Yeah, how many
Hmm.
B
So,
time?
b times, but how many brackets are left now?
Mm. N minus A.
N minus a brackets, no?
Yeah,
But a
Yeah.
brackets, so you selected x, right?
yeah,
Out of the remaining n minus a brackets, you have to select b y's, right? So
yeah,
Hmm.
yeah,
Yeah.
number of ways to do that would be n minus a c b, right?
yeah,
And after that, if you are following proper logic, you will realize that already the c's will be selected, right? The z's.
yeah, yeah,
Yeah.
Z's will already be selected because n minus a minus b is actually equal to c, right?
Hmm. Yeah. Yeah.
So, so to select, say, c z's from actually c brackets only, right?
mm, mm,
Because this many are left, no? N minus a minus b is equal to c.
yeah,
Yeah.
That is only one way, right? That is already
yeah,
done, right? Correct.
yeah,
So
Yeah.
total number of ways of making up a term like this will become this, right?
yeah,
Hmm.
Right.
Yeah.
This can be done in 2 ways and this can be done in 3 ways. Then total should be 6, right?
6, yeah,
So the answer, how many such terms will come, will be NCA multiplied by n minus ACB, right?
mm,
Into 1, correct?
yeah,
So if you simplify this a little bit, this becomes n factorial by n minus a factorial. This becomes n minus a factorial by n minus a minus b factorial b factorial
B factorial, yeah,
is equal to, cancel off this and write n minus a minus b as c, right?
yeah,
So you can say that this is equal to n factorial by a
A,
factorial b
A, B,
factorial
C
c
factorial,
factorial,
yeah,
right?
yeah,
So
Yeah.
many
Yeah.
different ways you can make this particular term, right?
yeah,
So the coefficient of this has to be this now.
yeah, correct,
I mean, that is the logic, na? The number of
yeah,
different ways you can make this term, that many times this will come, right? When you
yeah,
multiply
yeah,
it,
Yes. Yeah.
right?
Yeah.
So basically, now we have figured out that any term in this expansion which has powers xa, yb, zc has to have this coefficient,
yeah,
Yeah.
right?
yeah,
And like so on, now you have to do a summation of this so long as you satisfy a plus b plus c is equal to n, right?
yeah, yeah,
We basically have to answer now one question, that how many such terms are there, right?
yeah,
Summation goes
Yeah.
from where to where, right?
yeah, yeah,
That question is not yet answered. We know that if we are looking for a particular term, then the coefficient is easy to find.
yeah, yeah,
Yeah.
If someone asks you x plus y plus z to the power 5, what is the coefficient of x plus y plus z to the power 5? What is the coefficient of x power 4, y power 1, right?
yeah, yeah,
In this, then I know very easily that that will be 5 factorial by 4 factorial, 1 factorial, 0 factorial. So
yeah,
5,
Yes. Yeah.
okay? But
mm,
if someone asks you, write the expansion, right?
yeah,
Write
yeah,
the expansion of this, right? Then basically,
Hmm.
then it is slightly more annoying because you have to know how many ways can you add up a plus b plus c to give 5, right?
yeah, yeah,
Yeah.
Because
Yeah.
think about it, x, y, z, and this is 5. You can start with x is 5, this is 0, this is
0,
0.
0,
You can
yeah,
do 4, 0, 1, 4,
yeah,
1, 0, right?
yeah,
You can do
Hmm. Yeah.
3, 1, 1. You can do 3, 2, 0, 3, 0, 2, right?
yeah,
Nothing else
Yeah.
in 3, I think. Then you can do 2, right?
2,
Hmm.
I mean, and then things can be interchanged and this can become 5 and all, no?
yeah, yeah,
So there
Yeah.
is a
Yeah.
lot of possibilities, right?
yeah,
So you will have to figure out some way to realize how many such terms will come, right?
Yes. Yeah.
And each different arrangement, right, is different from each other.
yeah,
You understand that no term can be
Yeah.
combined because
yeah, yeah,
powers are always different, no? If the arrangement is different,
mm,
Yeah.
x
Yeah.
power 5, y power 0, z power 0 is different from x power 0, y power 5, and z power 0, right?
yeah,
So it's not like any two terms can be combined. So it's a clear-cut answer. The answer will come when you know how many ways can you solve this, right?
Yeah.
Correct. How many
Yeah.
different
Yeah.
arrangements are there, right? So let's think
Mm.
about how to get that. But first part is clear. What is the coefficient?
Yeah. Yeah.
Yeah, yeah.
That should be fairly clear. So anytime you need a coefficient, it is n factorial by a factorial, b factorial, c factorial, x bar a, y bar b, z bar c. And you
Yeah.
can
Yeah.
extend this for any number of variables, okay?
Mm.
The same thing will be valid. You can prove it in the similar way. If you want this series, right? And I want x1 power r, x2 power s, x3 power k, something powers, right?
Yeah.
W or whatever, right?
Yeah.
This
Yeah.
Yeah.
coefficient will simply be n factorial by r factorial, s factorial, k factorial
Yeah.
till
Yes, yeah.
w factorial. Okay.
Mm-hmm.
Yeah.
It's just that the number of terms is the more difficult thing to answer here.
Yeah.
Okay, so let's figure out that one. So let's say x plus y plus z to the power n, right?
Mm.
So we will try to figure this out using binomial theorem only. So what we will do is we will call this as a one variable, right?
Yeah.
So we can say
Yeah.
this
Yeah.
as p plus z to the power n, right?
Yeah.
So now we
Yeah.
know that there are n plus 1 terms here, right?
Yeah. N+1.
So the terms will look like this. It will be nc0 p power n z power 0 plus nc1 p power n minus 1 z power 1 plus so on, right?
Yeah.
P
Yeah.
power n
Yeah.
minus 2 z power 2 and so on till ncn p power 0 z power n, right?
N. Yeah.
And these together are n plus 1 terms, right?
Yeah. Yeah.
Yes, yeah.
Now individually inside also there will be an expansion, right?
Yeah.
Because of this p being x plus y, right?
Mm. Yeah.
Yeah, yeah.
So this becomes nc0 x plus y to the power n z power 0 plus nc1 x plus y to the power n minus 1 z power 1, right?
Yeah.
And so
Yeah.
on. So
Yes, yeah.
ncn x plus y to the power 0 z power n, right?
N. Yeah.
So how many terms come here due to just x plus y to the power n? N plus 1?
N+1 again.
N
Yeah,
plus
yeah.
1 terms here which will multiply with z power 0. So n plus 1 total terms will come from the first thing, right?
Yeah.
Yeah.
Here n terms will come,
Mm.
right?
Mm.
Because x plus y to the power n minus 1 will expand to give
Ah,
n,
yeah, yeah, yeah. N
Yeah.
terms, yeah.
Yeah.
and each of them you will multiply with z, so it will become n different terms, right?
Yeah. Yeah.
Yeah.
Notice that nothing can be combined, okay?
Mm-hmm.
This
Yeah.
is every term here will be different from every term here, right?
Yeah. Yeah.
Yes, yeah.
There is no confusion like you can add up some terms or anything, okay?
Yeah. Correct.
So every term is different because powers are always different, right?
Mm-hmm.
So
Yeah.
so n terms here. In the next one, it will be n minus 1 terms,
N-1 2.
and so on. You have to add. And this one, there is only one term, no?
Yeah.
Because there's z power n and this is 1, right?
Yeah. Yeah.
So this is going to be the sum of 1 plus 2 plus 3 till n plus 1, right?
Yeah. Yeah.
That is simply equal to n plus 1 into n plus 2 by 2, right?
Hmm.
Correct?
Yeah,
Yeah.
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 And that can be written as n plus 2 c2. Verify this. N plus 2 factorial by 2 factorial and n factorial, right?
Hmm. Yeah. Yeah.
So that is the same thing, right?
Yeah.
So now what we have gotten is number of terms of this series comes out to be this, right?
Hmm.
Yeah.
Okay. Now one value we have gotten. Okay, this is correct. We need one more value to be able to detect any patterns.
Yeah.
Okay. So let's try to do this one. So why don't you guys try to do this one? How many terms will come here? Number of terms. Number of terms in this series. Think in the same way. Make it as binomials, right?
Yeah.
Yeah, yeah.
Make it as binomials and try to figure out how many terms should come, right?
Yeah.
Okay, yeah.
Try it once.
Sir, in the p to the power n minus 2 q square, those kind of terms.
P to the power?
Suppose it's p to the power n minus 2 and q
Q
square.
square, yeah.
Yeah, so we'll get total.
You have to basically count a number of terms, right?
Yeah.
Is it n minus 1 into 3 for that?
For that
P,
one.
yeah, for that one.
P to the power n minus 2 into q square terms.
Yeah.
So
Yeah,
there are basically 3 terms here
3
and
into n minus 1.
n minus
n
1
minus
terms
1.
here, right? So it will be
Yeah.
adjacent to
Yeah.
this only, right?
Yeah.
It's like
Yes,
if
yeah.
there are 2 parentheses with x, y, z and some other terms, right? You have to multiply, right?
Mm-hmm.
Yeah.
So number of terms in this one will be 3 into n minus 1. So you can actually, instead of listing it out, you can do that also and then try to sum it. You can actually think in terms of the general term here.
Yeah, general term.
Here in this p to power n minus r, there will be n minus r plus 1 terms. And here there will
Yes,
be
yeah.
r plus 1 terms, right?
Yeah. Yeah.
Yeah.
And when you multiply, that will be the total number of terms in this one, right?
Yeah.
And you have
Yes,
to
yeah.
add all such things.
Yeah. Yeah.
Right, 1 second, hold on. So how will you get this addition? This is a straightforward addition. Just simplify it a little bit. This becomes n r,
Mm.
right?
Yeah.
Yeah,
R
yeah.
cancels here.
R cancel. Yeah.
N r plus n plus 1 minus r square, right? Summation.
Yeah.
Yeah. Yeah.
R goes from 0 to n,
Yeah.
right? So this n plus 1 is a constant.
Yeah.
So
So we
n
can
plus
take it
1,
out.
how many terms are here? N plus 1, right?
Yeah.
So n plus 1 into n plus 1 will become n plus 1 square, right?
Yeah.
Plus summation of n times r from 0 to n, right? Minus
Yeah.
summation of 0 to n r square, right?
Yeah. Yeah.
Yeah. Yeah.
Correct. So now you can do that easily. 0 to n, r summation is n into n plus 1 by 2,
Yeah.
n plus 1 whole square minus plus n into n plus 1 by 2 minus this becomes n into n plus 1 into 2n plus 1
2n
by
plus 1.
6,
Yeah.
right?
Yeah. Yeah.
Now you can take n plus 1 common from everything. N plus 1, let's take common from everything. It becomes n plus 1 plus n square by 2 minus n into 2n plus 1 by 6, right?
Yeah.
Yeah. Yeah.
Take 6 like this.
Same.
6n plus 6 plus 3n square, right?
Yeah.
2n square minus n, right?
Yeah. Yeah.
So inside part becomes n square plus 5n
5n.
plus 6 by 3, right?
Yeah.
Which is simple to factorize. It becomes n plus 1, n plus 2, n plus 3 by 3, right? By 6, right? Why am I writing 3?
6. Yeah.
Right?
Yeah. Yeah. Yeah.
By 6.
Yeah.
So by 6, this is coming, right?
Yeah. Yeah.
Now notice that this is n plus 3 C3. Check it.
Yeah. Yeah.
Right.
Yeah.
So now you will be able to, since we have got number of terms of this as n plus 3 C3, and number of terms of the previous one came as n plus 2 C2, right? Number of terms here came out to be n plus 2 C2, right?
Yeah.
Number of terms
Yeah.
here
Yeah.
came out to be n plus 3c3. Correct?
Yeah, yeah.
Then you can
Yeah.
now say a pattern is there, right?
Yes. Yeah.
So this is k times, if it was k terms were there, right?
Yeah.
Instead of
So
a binomial, if it was a trinomial, I do k minus 1, c
k
k
minus
minus 1,
1. Yeah.
right?
Hmm.
And it is 4, then 4 minus 1, c 4 minus 1, right? So if you
Yeah.
have x1 plus x2 plus xk to the power n, the number of terms will be n plus k minus 1 c k minus 1.
Yeah.
Yeah. Yeah.
Total number of terms. Okay, we can quickly verify it for, let's say, x plus y plus z to the power 3. We know the series of this, right?
Yeah.
X cube, I mean, I think I know this, but you can just expand it, right? X cube plus y cube, I don't remember it actually, but predicted answer should be what? 3 plus 2 c2, right?
Yeah.
5
Hmm. Yeah.
c2, so
Yeah.
that should
Yeah.
be 10. There should be 10 terms here.
Yeah.
Check it once. I mean, this expansion can be done because we know, okay, it will be annoying to do also. Just 3 will be annoying to do. X plus y plus z into x square plus y square plus z square plus 2xy plus 2xz plus 2yz, right?
Hmm.
Yeah.
Yeah.
Uh, See, it will not be actually 18 terms here because you will add up some terms,
Yeah. It's in 10 only.
right?
It's x cube, y cube, z cube, then 3x square y,
Uh,
3 x y
y
square,
square plus 3 y
y square
yz
z.
square,
Yeah, and y square z.
y square z.
And then
Okay,
x square
similar
z.
terms like this. Yeah, yeah.
Then last is x y z.
Hmm.
And
Yeah.
one
Yeah.
term will be xyz, correct?
Yeah, 6x y z.
So there will be 6 terms like this, right? No,
Yeah.
no.
Hmm. Yeah.
Yeah, 6
Six, three,
terms.
nine,
Yeah.
and one.
6.
Yeah. 6 terms like this will be there, right?
Yeah.
Hmm.
And 3 terms will be like this, and one term will be xyz, right?
X,
Yeah.
Y, Z.
Yeah.
Yeah.
So basically the formula is correct. This is what happens. Okay. This is the number of terms. Okay. So
Yeah.
multinomial theorem, now you know everything about it. It is basically saying x plus y plus z plus w to the power n, let's say, is going to be summation such that a plus b plus c plus d is equal to n, and this will be n
And
factorial by a factorial, b factorial, c factorial, d factorial, x plus to the power a, y power b, z power c, w power d, right?
Yeah.
yeah.
And this, why have I written this? Because I want to say that this summation has how many terms? It has n plus
And
3c3 terms.
C3. Yeah.
So
Hmm.
what you also realize from here is that the number of solutions, number of non-negative integer solutions, non-negative integer solutions to the equation, a plus b plus c plus d is equal to n must be what we have seen, how many terms are coming, how many different ways you can add this, right?
Yeah.
Must
Yeah.
be
Yeah.
n plus 3c3.
Yeah.
If you had k variables here, right?
Hmm.
It will be n plus k minus 1
K
c k
minus
minus
1.
1,
Yeah.
Yeah.
right?
Yeah.
This is non-negative integer solutions. You cannot have negatives, you cannot have fractions.
Yeah.
Hmm.
It can be 0
Yeah.
or positive. Okay.
Yeah. Yeah.
So although this part we will be studying in much more detail when we do permutations and combinations, next chapter we'll be studying in this part in a little more detail. But for now,
Hmm.
you know that the meaning is this, right?
Yeah. Yeah.
Yeah. Yeah.
Okay. So this is multinomial theorem. If you see the questions in your Allen book and all, it will be fairly straightforward for this chapter, this portion. Uh, I'll just look at one or two. So, for example, they're saying find the coefficient of x power 5 in the expansion of this. Okay, let's do one of them. Find the coefficient of x power 5 in the expansion of 2 minus x plus uh, plus 3x squared to the power 6. 3x squared to the power 6. Okay. So, okay. So I need coefficient of x power 5. But before I can do that, I should write a general term for this, right?
Yeah.
So this will be summation 6 factorial by a factorial, b factorial, c factorial, let's say. It will be 2 power a minus x power b and 3x square power c, right?
Yeah.
This is my series, right?
Yeah.
Yeah,
So
yeah.
I care about the x powers, right? So I will
X
write it
power.
as 6 factorial by a factorial, b factorial, c factorial, 2 power a minus 1 power b and 3 power c into x power 2c minus b, 2c plus b, right?
Yeah.
Minus 1 power b and x power b. So x power becomes 2c plus b, right?
Yeah. Yeah.
Yeah.
This is my general term. I need to ensure that 2c plus b is equal to 5, right?
Yeah.
Correct.
Yeah.
And I also have a condition that a plus b plus c is equal to 6, right?
Yeah. Yeah.
That has to be true always, right?
Yeah.
Yeah.
So these two things together should give me some candidate things, like in the sense that 2c plus b is this. So if you subtract this minus this, right? So you'll get what? C minus a, right? Is equal
Yeah.
to minus 1.
-1. Yeah. So, yeah.
So C is equal to a minus 1 comes.
Yeah.
Correct. If C is equal
Yeah,
to
yeah.
a minus 1, you will get 2 into a minus 1 plus b is equal to 5, right? So b is
Yeah.
equal to minus 2 and goes this side. So 7 minus 2a, right?
2A. Yeah. Yeah.
Correct. So what are the,
Yes, yeah.
see, these two equations are not sufficient to solve it completely, okay?
Yeah.
Because one equation has 3 variables, one equation has only 2 variables, right?
Yeah.
It's
Yeah.
impossible to
Yes, yeah.
actually solve it exactly. What you will get is all the values of a, b, and c in terms of any one variable
In
that you
terms,
choose.
yeah.
Yeah.
Right? So I
Okay.
have converted c to a minus 1 and b to b a 7 minus 2a, right?
Yeah.
So
Hmm.
my abc basically becomes a comma 7 minus 2a comma
A
a
-1.
minus 1, right?
Yeah.
Yeah.
Correct. So now put some values of a. A can start from where? Start from 0, right?
Yeah. Yeah.
A is 0, then what is coming? B is coming out to be 7 minus 0, 7, right?
Yeah.
So
Hmm.
0, 7, and C is coming out to be,
-1.
but that is
-1.
not allowed, right?
Yeah. Can't be.
That is not
Yeah.
allowed, can't be negative. So that is not a possible candidate, right?
Hmm.
So A is 1, right? Can't be negative y, right? You understood?
Yeah. Yeah.
Yeah, yeah.
Negative factorial is not defined also, right?
Yeah.
A is 1 is possible. So 1, 7 minus 2, 5,
5
and
and
0.
0.
This is
0.
possible.
Yeah.
Yeah.
This is a possible thing. A is equal to 2, then 2 and 3 and 1, right?
1. Yeah.
1.
A is equal to 3, then A, 3 and
B 1 and
1
1
and
and 2.
2. After this, it will not be possible. Why?
yeah.
Because A is equal
Yeah,
to
yeah.
4, this will,
-1.
right?
Yeah.
Negative.
No
Yeah.
other integer values are possible now.
Mm.
So these are the 3 values for which you will get the x power 5, right?
Yeah.
So now just find the coefficients. My general coefficient was this, right?
Yeah.
So put 1, 5, and 0 on that, right?
5 and 0.
So it will become 6 factorial by 1 factorial, 5 factorial, 0 factorial is 1, and
1.
2 power 1 minus 1 power 5, right?
Yeah.
Minus 1 and 3 power 0,
3
right?
power 0.
So this is just
So
6,
6.
6 into minus 2 into 1. So
1.
minus
Yeah.
12, right?
-12.
When you put 2, 3, 1, you will get another set of values, 6 factorial by 2 factorial, 3 factorial, 1 factorial, 2 power 2, so 4, minus 1 power 3, so minus 1,
-1.
and 3 power 1, so 3.
1. 3.
Right? So 6 by 2 factorial 3 factorial will be 720 by 6. So 120, right? No, 720 by 12. So 60. 60 into 4, 240 into 3, 720. So minus 720, right?
Yeah.
And
Yeah.
the last one will be 6 factorial by 3 factorial, 2 factorial, 1 factorial. The same answer will come 120 from here into 2 power 3, yeah, minus
Yeah.
1 power 1 and 3 power
3 square.
wait one second, 3 square, right?
Yeah.
Correct. So 120 into 8 into 9, right?
Yeah. Yeah.
72 into 120. So 72 into 10 is 7. What? 120 into, no, 60. This is 60, dude. This value is 60. 60 into 72. That makes more sense. 72 6 the 420, 432.
Yeah. Yeah.
So 432 minus 4320, right?
Yeah.
And add up all of them, it becomes minus 5020, 5040, 5052.
Yeah. Yeah.
That is the answer. Okay. That will be there maybe in your Allen book. I don't know if they've changed the example or not, but it might be there. Illustration 21 in the version that I'm using. Okay. So,
Okay. Yeah.
okay. So this was one of the more complicated ones. Normally, questions on this will be quite easy, like directly checking whether you know the meaning of multinomial theorem or not. Okay.
Yeah. Okay.
In this case, you actually had to find 3 different coefficients, right?
Yeah.
But that much effort is also not required in most of the questions, but it's fine. Anyway, you should understand what we discussed previously,
Yeah.
right?
Yeah.
And how we
Yeah.
are getting all of this, right?
Yeah.
Number of terms in this series will obviously be, see here, actually there is a problem in counting because the terms can combine and all, right? There is a
Yeah.
chance.
Yeah.
Because x and x, right? So
Yeah. It's the same.
it is difficult to count here because it will be annoying. So I will not be able to say here, but if it was A, B, C, right, it will be 6 plus 2 C2, 8
Yeah.
C2,
Yeah.
right? 8 C2 total terms, but here there could be combinations. Like here, for example, these 3 different terms added up to become x power 5, right?
Yeah. Yeah.
Yeah. Yeah.
That is what I mean. Like here they can combine together, right?
Yeah.
Otherwise, if they were different variables, you could have counted them separately.
Yeah.
Okay. This is one. Then the next, this is a slightly different type. This type of question is basically an application. So let's look at this. So question is, if 6 root 6 plus 14 to the power 2n plus 1, okay, 6 root 6 plus 14 to the power 2n plus 1 is equal to GIF of n plus f. Here, f is equal to n minus GIF of n. Basically, f is the fractional part of capital N. Okay. You understand the meaning of GIF and fractional part, no?
Yeah.
Yeah.
So,
Yeah.
okay. Then what is he asking? Find n into f. Okay. So let's think about first of all what it means. He's saying this thing will be some number, right?
Yeah.
It will be some number and it could be some decimal type of a number, right?
Yeah.
That thing is called basically n, right?
And
Because if you put f as n minus this, it's just n, right?
yeah. Yeah.
This is n.
Yeah. Yeah.
This n basically has 2 parts, this and this, right?
Yeah.
This is the integer part and this is the fractional part.
Fractional part. Yeah.
Now, what he's asking you to find is n into the fractional part, right?
Yeah.
Okay. So this type of question, it is very convenient often to think of the conjugate expression of this. Conjugate expression, by that I mean 6 root 6 minus 14
Minus 14.
to the power 2n plus 1. Okay. So
Okay, yeah.
Why is that conjugate expression going to be useful? Because notice that if you multiply these two, right, what comes? It becomes 216 minus 196, right?
Yeah.
Correct. So 20 to the power 2n plus 1 will come, no?
Yeah. Yeah.
Correct.
Yeah.
Okay. So multiplication will give some nice answer. Roots will be eliminated because it's a conjugate, right?
Yeah.
So let's call this for now some f dash. Why am I calling it f dash? Because I noticed that this 6 root 6 and 14, right? 6 root 6 is technically root 216, right?
Yeah.
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 And this is root 196, right?
196. Yeah.
So root 216 will be 14 point something, no? Because 15 square is 225.
Yeah.
Yeah, yeah.
Yeah.
And this is 14, right?
Yeah.
So technically the value of this is less than 1, no?
Yeah.
Yes,
Yeah.
yeah, less than one,
The
yeah.
value of this thing is less than 1. So power 2n plus 1 will be still less than 1.
Less than one. Yeah.
So f
Yeah, yeah.
dash is like a fraction only. That's why I'm calling it f dash.
Yeah.
Okay, okay,
It
yeah.
doesn't have to be f. It could be
Hmm.
something else, but it is definitely a fraction,
Fraction. Yeah.
right? So I know that. So now what I will see is what is the value of I plus not that. What is the value of n plus f? N plus f dash, right?
Yeah.
N plus f dash or n minus f dash. I will check either of these things. Okay. So let's think about why am I doing that? Because this is a binomial theorem series and this is a binomial theorem series, right?
Yeah.
So and they are very similar to each other. With this one will have alternating signs, right?
Yeah. Yeah.
Correct. So if you add or subtract, some parts will get cancelled, right?
Cancelled. Yeah.
So that is
Yeah.
what I'm aiming for here. So think
Yeah.
of this 6 root 6 plus 14 to the power something. That series will look like everything will be plus plus 2n plus 1 c0, 6 root 6 to the power 2n plus 1 plus 2n plus 1 c1, 6 root 6 to the power 2n, and then there will be a 14, right?
Yeah. Yeah.
And so on and all. And if you do 6 root 6 minus 14 to the power 2n plus 1, right? It will be similar first term, but negative second term.
Negative second term. Yeah.
Negative second term, 6 root 6 to the power 2n and 14, right?
Yeah.
So actually, what I want to do is subtract here. Why subtract? Because if I add, what will happen? What terms will remain for me? This first term will remain, no?
First term. Yeah.
Third term will remain.
Yeah. Yeah.
First term, third term, fifth term, those terms will remain, no?
Yeah.
And if first
Yeah,
term
yeah.
remains, then root 6 has an odd power on top of it, right?
Yeah. Yeah.
I don't want odd powers because odd powers means radicals are going to be left over, right?
Left over. Yeah.
So I want to subtract so that I can cancel the first term, right?
Yeah. Yeah.
If I subtract, I will be left with this terms, right?
Yeah.
The
Yeah.
Yeah,
second
yeah.
and fourth term and so on, right?
Yeah.
So the subtraction of this minus this. So basically this plus f minus f dash should be equal to the sum of this second term 2 times, right?
Yeah.
Plus fourth term 2 times, right?
Yeah. Yeah.
I'll write 2 times 2n plus 1 c1, 6 root 6 to the power 2n into 14, plus say 2n plus 1 c3, 6 root 6 to the power 2n minus 2 into 14 power 3, right?
Yeah.
And
Yeah.
so on. No?
Yeah.
Yeah,
Yeah.
yeah.
Notice that the powers are all even, right?
Even. Yeah.
So this will become an integer, right?
Yeah.
Because
Yeah.
root 6 will be cancelled out, right?
Cancel.
It will become an integer basically, right?
Yeah,
Yeah.
yeah.
So what we are getting is this side is an integer. Right hand side comes out to be an integer, right?
Yeah.
Right hand side definitely comes out to be an integer here.
Yeah. Yeah.
So now we have a relationship saying n plus f minus f dash is equal to integer, right?
Yeah. Yeah.
Yeah, yeah.
And this is an integer. So basically we know f minus f dash is an integer, right?
Yeah. Yeah.
f minus f dash is an integer where we know that both f and f dash are between 0 to 1, right?
0 to 1, yeah.
Yeah.
Right? So what are the integers possible? The integers that are possible could be 0, could be 1, could it be even 1? I don't think it's
No, it
possible to be
can't be
1
1.
also.
Can
No.
be only 0, so
It
it's
has to be
same.
0, no? Because it cannot be 1, otherwise f will become greater than 1, right?
Yeah,
Yeah. Yeah.
So it has to be an integer, then it has to be 0, right?
0, so f is equal to,
F is equal to f dash comes, right?
yeah,
And now you want to find out n into f, right?
yeah, that
N
is
into f dash, that becomes 6 root 6 plus 14 to the power 2n plus 1
6 root 6
multiplied by
minus
6 root 6 minus 14 to the power 2n plus 1,
4. Yeah.
and that becomes 20 to the power 2n plus 1.
Mm.
That is the answer.
Yeah.
Okay. So obviously right now I'm explaining, that's why it is taking so much time. But otherwise, generally when you have seen a few of these, right,
Yeah.
you will realize what has to be done immediately, because what you have to check is always uh, check the basically conjugate expression, right? So here
Yeah.
5 plus, suppose 5 plus 2 root 6 to the power 10, right? I
Yeah.
will check the 5 minus 2 root 6 to the power 10, right?
Yeah. Yeah.
And I will either add it or subtract it, right?
Subtract it. Yeah.
To
Yeah. Yeah.
ensure that what I am left with is going to be an integer.
Yeah. Yeah.
Okay. So in some cases you could have a uh, if it is like this, I would probably do the same thing that I just now did, right?
Yeah.
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 I would probably do the same thing that I just now did, because I want to remove the root terms.
Root terms. Yeah.
I want to preserve it as an integer. So I will probably subtract here. I will just write 2, 3 terms and see what will work out for me, right?
Yeah.
And this
Yeah.
part
Yeah.
will be basically n plus some fraction. And this part I know is already some fraction and all,
Fraction. Yeah.
right? So f dash, let's say. So if subtraction gives out, if subtraction of the two things gives an integer, then I'm sorted, because f minus f dash will be 0, right?
Yeah. Yeah.
Then f will be equal to f dash.
F
In
dash.
some
Yeah.
cases, you have to add and do it. So in that case, we'll get n plus f dash is equal to integer, right?
Yeah.
F
Yeah.
plus f dash is equal to an integer will come, right?
Yeah. Yeah.
If you have to add and do it, it will be this, right?
Yeah.
In that case, it cannot be anything other than 1.
1.
It cannot be
Okay.
2,
Yeah.
okay?
Yeah. Yeah.
Because both are less than 1, right?
Yeah. Yeah.
And it cannot be 0 also, because none of them is negative.
Negative.
Ensure that both of them are non-negative, right?
Yeah. Yeah.
And then obviously you know that f dash is equal to 1 minus f, right?
Yeah. Yeah.
And then something will be asked, but you know this nice thing, right? F dash you
Yeah.
know is the conjugate expression, right?
Yeah.
This is going to be what will solve the question. Something will be asked. They might ask something n f minus f something. I don't know, right? I forgot the question, but either it will be f dash is equal to 1 minus f, or it will be f dash is equal to f.
1.
And it will come either by, here it will come by addition, or here it will come by subtraction of the
Subtraction.
conjugate binomial.
Yeah.
Okay. And the logic is that it is integer on one side, so the remaining, the fractional part should add up to an integer or subtract to form an integer.
Yeah. Yeah.
Yeah. Yeah.
Okay, so this type of thing you will encounter several times, so it should be fine. Then more or less the chapter is done. There are some 1 or 2 things that are there. So for example, binomial theorem for negative or fractional indices, right? So okay, if n belongs to rational number, if n belongs to q is the set of rational numbers,
Yeah.
then 1 plus x to the power n, right? Now obviously you cannot expand it as nc1 and all.
Yeah, yeah.
That doesn't make any sense because you cannot take some out of some
Half you can take
fractional
one.
parts, you cannot take one and all, right?
Yeah.
Fractional number of things doesn't
Yeah,
make
yeah.
sense only, right? So actually the expansion of this is just what is the meaning of this if you write it down in terms of n, right? This is just n, right?
Yeah.
What is nc2? It is n into n minus 1 by 2.
Yeah, yeah.
nc3 is n into n minus 1 into n minus 2 by 1 into 2 into 3, right?
Yeah, yeah.
So the expansion of this is actually the same thing, but just written like this.
Mm-hmm.
You understand?
Yeah, yeah.
Expansion is the same, it's just written
Same.
like this because this definition doesn't make sense, but the values are still the same.
Mm. Yeah.
Okay.
Hmm.
However, this series now extends till infinity,
Mm-hmm.
provided mod x is less than 1. If mod x is greater than 1, right,
Yeah.
then it is not defined. There is no expansion then. Okay.
Mm-hmm. Mm-hmm.
And if mod x is less than 1, then you can define it as a series like this, which goes on
Yeah.
till infinity.
Okay.
Okay. The proof
Yeah.
of
Yeah.
this is right now not in syllabus, in the sense that fractional coefficients, fractional indices binomial theorem is definitely beyond the scope of JEE. So we will not be worried about the proof so much. Make sure that you check that your mod x is less than 1 and only then write it like this. Okay.
Yeah, yeah.
Sometimes what could happen is they could give you things where it is not immediately certain that you could have 3 plus 2x, right, to the power n, right?
Mm-hmm.
Yeah.
And n is some fraction. Okay.
Yeah.
So the series is a converging or a finite value. I mean, defined. The series is defined only when mod of 2x is less than 1. Or first thing to do here is actually take 3 out. 3 power
Yeah.
n, 1 plus 2x by 3, right?
Yeah.
Hmm.
Then say that this mod has to be less than 1, only then I can expand it.
Mm-hmm. Yeah.
Mod of
Okay, okay.
2x by 3 must be less than 1. Then I can write it as 1 plus n into 2x by 3 plus n into n minus 1 by 2 into 2x by 3 whole square and so on,
Yeah.
right? And outside there will be a 3 power n, right?
Yeah. Yeah.
Yeah.
You understand? So that is the way you do it. Now, in a similar fashion, if you have index is a negative integer, right?
Mm-hmm.
Index is a negative integer, then we'll apply the same logic 1 plus x to the power minus 1, suppose, right?
Yeah.
Again, it will be an infinite series. And let's assume that mod x is less than 1, right?
Yeah. Yeah.
Then I will write the series as 1 plus nx plus n into n minus 1 by 2 into x square plus n minus 1 n minus 2 by 1 2 3 x cube and so on, right? And I will put the value of n. When you put the value of n, what happens is 1 minus x plus minus 1 into minus 2, right? Correct?
Yeah. Yeah.
So minus 1
Yeah,
into
yeah.
minus 2 is plus 2 by 2. So x square, correct? Then
Hmm.
this one becomes minus 1, minus 2, minus 3, right? So everything cancels, but minus remains,
Yeah. Yeah.
plus x4 minus x5, and so on is the answer for this
Mm.
one.
Mm.
1 plus x power minus 1 or 1 by 1 plus x.
Yeah.
Okay. Uh, 1 second. Have I told you about Taylor series earlier at some point? Taylor series expansion of some functions during calculus while talking about, I mean, if I mentioned have I mentioned briefly anywhere Taylor series and all?
I don't think so.
F of x is equal to something like this. F of x is equal to f of 0 plus f dash 0 x power 1 by, no, right?
No,
I
no,
have not mentioned this, no?
no.
Okay, fine. Right now, then we'll not discuss that. We will do it later. So this series expansion everyone has understood.
Yeah,
So in case I had 1 minus x to the power minus 1, right?
yeah.
I would have done the same thing except put minus x instead of.
Minus x, yeah.
So if I put minus x here, it will be 1 plus x. And if I put minus x here, then it remains unchanged, right? This one.
Mm.
And this one becomes plus x cubed, right? So actually, this is a completely positive series.
Yeah,
So basically, 1 by 1 minus x is equal to this. But this goes on till infinity, and this series also goes on till infinity. All of this is valid only when mod x is less than
mod
1.
x. Yeah,
Yeah.
Okay, otherwise it will not be valid.
yeah.
Okay, so again, he has given some more examples also, but everywhere the same process is being done. You understand the process now?
Yeah.
1 minus x to the power minus 2, right? I am just going to avoid writing nc1, nc2. Ultimately, I am doing the same thing.
Yeah.
I'll just not write it like that. So it will be 1 plus nx. N is minus 2, x is minus x, right? So plus 2x
So 2x, yeah.
plus n into n minus 1. So uh, minus 2 into minus 3
Minus 3. Yeah.
by 2 into minus x whole square, right?
Yeah.
So this becomes 3x square, right? 1 plus 2x plus 3x square plus 4x cube and all that. So on is the series.
Mm-hmm.
Correct?
Yeah.
Okay. Let's do a question, a couple of questions. There is one question in the book that I am seeing is, let's say this question. Let r is equal to uh, 8 plus 3 root 7 to the power 20
Mm-hmm.
to the power 20 and prove that GIF of R is odd, and B, R minus GIF of R minus GIF of R is equal to 1 minus 1 by 1 minus 1 by 8 root 3 plus 7, 8 plus 3 root 7 to the power 20. This is the question. So notice one thing, that this is 8 plus basically root 63,
Yeah.
right?
Yeah.
So if you take the conjugate expression, that will be
64.
so clearly less than 1, no?
Yeah.
So let's call this as f
Yeah.
dash, right? And r can be written as GIF of r plus f, right?
Mm-hmm.
Why am I writing this one 8 minus root 63 to the power 20 as f dash,
Yeah.
right? Because
Because
it is
it's
less than 1.
less than 1.
Yeah, it's less than 1.
Because it is less than 1, that's why we are calling it as f dash.
Yeah.
Now, the idea is to try to get whether addition will work here or subtraction, right?
Yeah.
So if you add, right, you will retain uh, NC0, NC2, So just write down a few terms, you'll get the sense of what to do. You understand what is happening, no?
Yeah, we'll have to
Wait, I should do 20C0, I should do. This is 20C1,
one.
right?
Yeah.
This is 2. And if I add it, this will get cancelled. So I'll be left with these type of terms, with square terms, right?
Yeah. Yeah.
Addition is making more sense, right?
Yeah. Addition.
So you get I plus f dash.
Yeah.
So f plus f dash is 1,
Plus F.
right? Because I plus f plus f dash is an integer came, no?
Yeah. Yeah.
Because this terms will become integer, no?
Integers. Yeah.
F plus f dash is 1, so f dash is equal to 1 minus f, right?
Yeah.
Or f is equal to 1 minus f dash and 1 minus 1 by f, because f into f dash is 1, notice.
Yeah. Yeah.
F is equal to 1 minus 1 by f, right?
Yeah. Yeah.
Makes sense.
Yeah.
I hope this is clear. If there are any
Mhm.
doubts on this, you should ask now. You can check f into f dash is coming out to be 1, no? So I'm using that
Yeah.
in the last
Yeah.
step.
Hmm.
Yeah.
Okay.
Yeah.
Uh, Fine. So with that, we are near the end of the chapter. Uh, you have the Allen book for this, the new one.
Yeah.
Yeah.
Okay. So new books have subjective exercises.
Yeah. It does.
Yeah, they do. Yeah.
Okay. Okay. So try the Allen subjective exercise now, and if you have a PDF, if you can send it to me, I can also see. Then we'll discuss some selected questions in the next class.
Okay.
Okay. Or but at anyway, start attempting. What is going on in your class at actually right now?
It is complex
Complex
numbers.
numbers.
Okay. Complex numbers you guys are doing. The next test is when?
Next test is now 30th.
Yeah.
Okay. Fine, fine. So they will start after that binomial and PNC, right?
Yeah. Yeah.
Hmm.
So
Yeah.
by then you should be in a good position if you are solving the exercise from now on. You should
Hmm.
be fine with that.
Yeah.
Also, complex number exercise also you should attempt from your book.
Yeah. Yeah.
Yeah.
Okay. That's it for now then. Tomorrow we'll do a class, okay? In the morning, right?
Yeah. Man.
Everybody is
Yes, sir.
free,
Yeah.
no?
Yeah. Man.
Okay. So 9:30 hopefully do a class. Okay. Bye.
Yes, sir.
Bye, sir.